So in this example problem, we're given the values of three forces. So we know the magnitudes of force 1, force 2, and force 3, and we're also given the directions of force 1, force 2, and force 3. We're asked to determine what is the magnitude and the direction of the resultant force of our three due to these three forces. So what we can say is our resultant force is going to be equal to F1 plus F2 plus F3. Okay? So the first step we're going to do is we're going to write F1, F2, and F3 as Cartesian vectors. All right? All right. So we'll start with force 1. Force 1, we know that the magnitude of force 1 is given as 400 newtons, and it's drawn along the negative x-axis. So it's just going to be, its Cartesian vector is just going to be equal to minus 400 newtons times the unit vector I plus 0 newtons along the y-axis. All right. For force 2, we're given that force 2 is has a magnitude of 250 newtons, and we know that it's at a 45-degree angle with the y-axis. So we can say that its x component is going to be equal to 250 newtons times the sine of 45 degrees times the unit vector I plus 250 newtons times the cosine of 45 degrees times the unit vector j. Okay, so that's, if we multiply those all out, that's around 176.78 newtons along the positive x-axis, and again 176.78 newtons along the positive y-axis. Then for force 3, we are given that its magnitude is equal to 200 newtons. All right, and if we use the 3, 4, 5 triangle, proportional triangle that's drawn along its direction, we would know that the x component of the force would be equal to 4/5 minus 4/5 times 200 newtons. And then the y component of the force would be equal to 200 newtons times a positive 3/5 times j. All right, so if we multiply those all out, F3 is going to be equal to minus 160 newtons times I plus a positive 120 newtons times j. Okay, so once we have that, all of our three forces written in Cartesian form, we can then just sum them all up to all the sum them all up to find our resultant force. So just recapping, our resultant force is equal to the sum of all the x components times I times the sum of all the y components times j. So if we just sum all of our x components together and we sum all of our y components together, we'll get our resultant vector. So our resultant vector would be equal to minus 400 newtons plus 176.78 newtons minus 160 newtons in the x direction, and then in the y direction we would get 0 newtons plus 176.78 newtons plus 120 newtons. So if you do all that math, what we end up getting is minus 383 newtons times I plus 296.78 newtons times j. All right. So that is our resultant force in Cartesian form, but the problem statement asks us to determine the total magnitude and the direction of our resultant force. Okay, so what we're going to do here is we already know R is equal to minus 383 newtons along the x-axis, and it's equal to about 297 newtons along the positive y-axis. Alright, so we want to know for our force vector r, what is its magnitude, and what is the angle theta from the positive x-axis. So r, we're going to get, this would be equal to minus 383 newtons squared plus 297 newtons squared, which would be equal to 485 newtons. And then theta, we're going to say is going to be equal to the inverse tangent of our y component, which is 297 newtons, divided by our x component, which is equal to minus 383 newtons. So if we solve that, we end up getting 142 degrees. All right. So to sum up our problem, we broke force 1, force 2, and force 3 into our Cartesian vectors using the geometry of our problem from the problem statement, from the diagram. And once we had our forces in the x and y components, we added them all together to determine our resultant vector in Cartesian form. Here. And the last step was to take that Cartesian vector and use the Pythagorean theorem to calculate the total magnitude, and use the inverse tangent function to determine the angle with the x-axis.